Still record is on. Okay. I will try to turn on my entire screen. I don't know why it's maybe I'll be out of the okay. I'll move back to here. Okay. Can you see, everybody can see this slide?
Yes, sir.
Okay. In chapter 5 is I will try to explain it. What is probability, experiment, event, and outcome is learning object 1 and 2 is a kind of definition. Okay. So like probability is likelihood to a particular events may happen, but probability 0 it cannot happen at all. 1 is always open. 50 is like half and half. When you toss a coin, single toss of coin, head will appear 50%, tail may appear 50%. And that's likelihood. The slowpoke is some sports teams in Kentucky Derby. Then in many cases, 80% they may lose. It keep somebody entering, interrupt me. Then I'll try to use not slideshow. I will try to open my PowerPoint like this. Okay. Point 7 is increase the federal tax is more than 50%. 70% they may increase. Not increase maybe 30%. It's based on maybe the historical experience and so on. When you see these two, YouTube, you may learn what is probability and so on. It's some you can have some brief ideas. Now, terminal experiment is a process that leads to occurrence of one of several possible experiments. One experiment is when you do a roller dice, okay? Roller die, possible outcome is maybe 1 will appear, 2, 3, 4, 5, 6. For possible events, and what you are interested in, observe even numbers. This even number, 2, 4, 6, or odd numbers. Or sometimes you may observe a number greater than 5. Maybe number 5 or 6 will appear, or a number of 3 or less, 1, 2, or 3 may appear. Okay. Another one is like when you see board members, count the number of members of board of director. BOD, it is short word, board of director of the corporation for Fortune 500 companies who are over 60. How many board members are over than 60? Maybe nobody. Maybe 1 person, 2 person, 29, 48. It depends on the company. The possible event means a collection of 1 or more outcome of experiment is more than 13. More than 13 board members are over 60, or fewer than 20 board members are over 60, and so on. So it depends on what you are interested. For example, coin, tossing coin. Tossing a coin is experiment. Or possible event head or tail. Only 2 things. Some possible event is if you think head will appear, you may say it is a success. Tail appears, you may say it is a fail. Then head will be a possible event for you. So you can choose like this. Classical event, classical problem. Classical probability. Classical. When there are n equally likely outcomes is there. For example, look at the die. When you roll a dice, is die like this, 1 will appear, 2, 3, 4, 5, 6. This 6, every face has equal likelihood. So 1 will appear the probability 1/6. 2 is another 1/6. 3 will appear the probability is 1/6. Every numbers will have same number, same likelihood. But then you toss a coin like this. Head will appear half. Tail will appear on half. Okay? So the classical means theoretical, a kind of classical means based on theoretical. So what I mean is, for example, toss a coin, head and tail will appear half and half. The theory. Try if you have any coin in your, I don't know whether you have coin. Try to 10 tosses, 10 times. Try to toss your coin 10 times. Head will appear maybe 6. Tail may appear 4. Then probability is 6/10 or 4/10. Okay, that's your experiment yourself. Your experiment is called, when you get probability based on your experience, it's empirical. It's called empirical probability. It really happened to you. You do your own experience, your experiment is called empirical probability. But even though I do not toss a coin, I already know head will appear half and half. Theoretically, head and tail has exactly same probability, likelihood to be appeared on the surface, you know. So it will be half and half, it classical or theoretical probability. But when you experiment yourself, is 6/10 and 4/10 is called empirical probability. The empirical probability means number of times the event actually occur. Okay, it is when you do yourself, it's actually happen divided by number of observation. It's empirical. For example, sometimes I will try to delete. For example, head and tail, if I assume is head, tail, you try it 10 times. It may happen 7 times. 7 head, 3 tails. For example, if you toss 100 times, it's maybe 60 to 40. With 1,000 times, it will be over 5149. Only 100 is, I will try to 1,000 or 10,000 times. It's almost try to 5,000. Empirical probability is sometimes empirical is not equal to classical. When you're tossing a coin, the classical probability is half and half. It's quite different. But when you try and repeat your experiment again and again, when your number of trial, experiment number is n increases, what will happen? Actual empirical probability will be close to classical probability. It will be similar when n becomes bigger. Okay, over a large number of trials, the empirical probability will approach a true probability means classical probability. Okay, when you repeat and repeat your trial, it will be close to the true probability. You need to understand what is the definition of classical probability and empirical probability. You need, I will erase. Wait a minute. Okay, when you repeat and repeat your experiment, the number of trials increases. Empirical probability will be similar as classical probability. Do you understand? In classical probability, we need to understand two important. One is mutually exclusive. Another one is collectively exhaustive. Mutually exclusive means occurrence of one event means that none of other events can occur at the same time. What it means? When you roll a dice, one will appear, but when one will appear on the top, one. If it is not mutually exclusive, 1 and 2 may appear together. Each 6 face of dice has mutually exclusive. 1 appear, 2, 3, 4, 5 will not happen again, will not show on the top. If 2 is appears on the top, 1, 3, 4, 5, 6 will not appear at all. It is called mutually exclusive. Another one is coin. When head appears, tail will be on the bottom. When tail appear on the surface, the head will be at the bottom. Head and tail, both of head and tail cannot appear at the same time. One appear, the other one should not appear at all. It is mutually exclusive. Do you understand? Collectively exhaustive means at least one of the events must occur. So it means collectively at least, one head and tail. Okay, every possible events are head or tail, but you cannot, when you toss a coin stands vertically. It's not head, not tail, nothing happened at all. The outcome is only head or tail, nothing else. How about when you roll a dice, 1 or 2, 3, 4, 5, or 6 will appear. 7 cannot happen. 0 cannot happen. 8 cannot happen. Okay, 1, 2, 3, 4, 5, 6. All 6 will represent all possible outcomes. And it's collectively exhaustive. You need to understand theoretical, classical, and empirical probability. Row of large numbers. When over a large number trial, empirical will approach means will become closer to its true probability. Third definition is subjective. Subjective means individual. It depends on you. It's by one individual's perception or experience, based on whatever information available. So, for example, New England Patriot is American football sports club in Boston. Okay, Boston area is called New England. New England Patriot is a football team. What is likelihood the New England Patriots will be in Super Bowl? Super Bowl means during the year they have lots of league games, many games, and the Super Bowl means 2 top teams will compete for the champion in the Super Bowl. Next year, New England Patriots will be in Super Bowl. The likelihood for estimation, we do not know what will happen, So subjectively, if you are a fan of New England Patriots, you say likelihood is maybe 80%. 90%. You may say that each person has a different number. If you are Florida, well, I forgot the sports club name. If you are Florida teams, fan of Florida team, your subject probability of the likely New England Patriots will be like 10%, 20%. It depends on person, individual's probability based on your experience, your understanding. Everybody has different information. Everybody has different understanding of information, different wishes, and so on. Subjective probability. So now, in economics and management, we cannot use subjective probability. So do not use subjective probability to make any business decision making. You need to use classical probability. Classical probability theoretically, okay, this is called, or empirical. Empirical means sometimes theoretical classical probability is not available. Then you need to collect data. You survey yourself, and you have, based on your survey, it is called your previous historical performance is called empirical probability. Okay. Any classical theoretical probability is available, try to use this one, or based on your historical performance, or on some survey, it will be empirical probability. In business, classical empirical probability will be widely used. Please do not use subject probability at all. So this is approach to probability. Objective, theoretical, classical, and empirical is objective, but the subject probability is based on personal and available information. So to not use this one. Do not use, sorry. Do not use this one. Okay, you can use either one. If you believe each outcome has equally likely outcome is a theoretical classical probability. Another one is relative frequency, usually survey collected data, okay, historical. So based on last year performance, 2 years ago, 3 years ago, and so you collect data. So based on relative frequency, then it will be empirical. Classical empirical probability is widely used. Okay? Now, learning objective 3 and 4. Now I moved here. Rule of addition, rule of multiplication. So addition means, read carefully, the rule of addition refers to probability that any two or more events can occur. So it means when events are mutually exclusive, for example, A, B, C, there is no commonality. If A, when you draw a Venn diagram, that this area is A and B, A and B, both A and B may occur. But in this case, A appears and B never appears because it is not totally separate. A, B, C, all three are totally separated. So in this case, or A or B. Another one is P, A, copy, or. In this case, it's mutually exclusive. There is no common. Mutually exclusive P, A, and B. Both in A and B may occur, it is completely zero. And some students come in. Please enter the classroom on time. Okay, latecomers interrupt my PowerPoint presentation and so on. So when you have where is my pen? Okay, mutual exclusive means A and B which will come. This probability is zero. Okay, mutual exclusive. So P A or means copy, or B means PA plus PB. So let's say if mutual is what is PA or B or C. A or B or C, anything happen is PA plus PB plus PC. Okay, so you need to understand this definition like that. Another one, if it is not mutually exclusive, what will happen? It's mutually exclusive, yes. If it is not mutually exclusive, not mutually exclusive means like that. A, B, there is some common areas here. The total is outside. Then what is P, A, or B means, or means like this. This one is PA plus PB. And then what will happen? The shade area is counted twice. So you need to minus P, A, and B. Because the shaded area is, when you hear this plus this, so this area is counted twice. So you need to subtract this one. If it's not mutually exclusive, you need to include this part. In addition, you need to understand, if the events are mutually exclusive, this is correct. If two are not mutually exclusive, the A or B is equal to PA plus PB minus PA and B. If mutually exclusive, this part will be zero. Okay, then it will go back to like this. Everybody understand this one? Do you understand?
Yes, sir.
And then I will go to example. A machine fills a plastic bag with a mixture of beans, broccoli, and other vegetables. Most of the bags contain the correct weight, but because of variation of size of beans and other vegetables, a package might be underweight or overweight. There are three possible: underweight, satisfactory is on, and overweight. Underweight is, we call it, is event A, event B, event C. Okay, so we tested 4,000 packages, total 4,000. Among 4,000, 100 packages is underweight, 3,600 is satisfactory, 300 bags are overweight, event C. Okay, then what is probability? That means 100 divided 4,000. 100 divided 4,000 is 0.025, 2.5%. Satisfactory is a P. What it means? This is PA, event of underweight. Second one is 3,600 divided by 4,000. Then this is called PB. over PC, this is calculated 300 divided by 4,000. When you add up, the total is 1.0. Summation PA, PB plus PC is total 1.0 if ABC are mutually exclusive. When you check the bag is underweight or satisfactory over overweight, you cannot say P, A, and B. Underweight and at the same time satisfactory, it is completely zero. It may not happen. P, A, and C. Underweight and overweight at the same time, it's zero. P, B, and C. Satisfactory and overweight, it may not happen, It's mutually exclusive. Event A, B, and C are mutually exclusive. Okay. The question is, what is the probability that a particular package has either underweight, the underweight is A, either or means unity is it is or. So P, A, and C, underweight or overweight. So PA plus B. So you cannot use PA and C. Is zero. It may not happen at all because they are mutually exclusive. It's mutually exclusive. A or B is just addition. Okay, addition will be enough. It is you need to add up. Mutually exclusive addition will be enough. You don't need to subtract. P, A, and B is not necessary. But if it is not mutually exclusive, you need to subtract something. Complement rule is, you need to understand what is complement. Complement rule is determining probability of an event happening by subtracting not happening. So exactly the same thing. So A or C. A or C means another one is not B. Okay. This means not B. P not B is B is satisfactory. Not B means not satisfactory. It's not satisfactory means underweight or overweight. So you don't need to calculate P A plus PC. Another one is total is 1 minus PB. Not B means 1 minus PB. They are mutually exclusive and collectively and exhaustive and so on. So it's not happening an event. So this is here is probability that not A occur. So it means 1 minus PA. PA is 1 minus not a probability, not A. So you can use this complement rule also. Addition rule, you studied addition rule, and complement rule is learned. General addition is like that. I have read it. If they are not mutually exclusive, general rule is PA plus PB minus A and B. So it means this part is added twice. You need to subtract PA and B. Event A, event B will happen together at the same time. Is joint probability. The probability measures the likelihood 2 or more events will happen concurrently at the same time. So it is not equal to 0 if they are not mutually exclusive. In that case, you need to subtract. example. We have surveyed 200 tourists in Florida. So we asked them, where are you going to? 120 out of 200 will go to Disneyland. 100 go to the Busch Garden. 60 visit both. So when you add up 120, 100 plus 60, just add up 280. You see, we have 200 tourists. But what it means, what this number is bigger than, because some people go Disneyland and Busch together at the same time. Some, some years 60. Let's say this is A, and this is D and B. Yes, PB and PD, PB, and both. Yes, 60. So divide by 200, 200, 200 is when you 0.6, 0.5, 0.3. 0.6 plus 0.5, 0.3. Even the first two, when you add up, bigger than 1.1. So you need to subtract, because this area joint probability is calculated twice. When you add up, some people go to Disney or Busch is 0.8. So I mean, what happened 0.2? They didn't, not Disney. They didn't visit, and they didn't visit the Busch Garden. Not visited Disneyland at the same time. They never visited Disneyland or Busch. They visited something else. So how many people? 1 minus 0.8. 20.2. 20% tourists may visit some other places. So going to Disney, going to Busch Garden, they are not mutually exclusive. Visiting Disneyland Busch is not. They are not mutually exclusive. Okay. Everybody understand this one? So addition rule, PA. So I will summarize here. Just simply you must P, A or B is PA plus PB. If you just make P, A, and B, you can memorize this one. This is a general rule. If A and B are mutually exclusive, P, A, and B both cannot happen if it is equal to 0, then this formula will be A or B is equal to PA plus PB. Is mutually exclusive? Yes. If they are A and B are not mutually exclusive, first formula you need to remember. For me, usually I do not memorize this one. The first one is meaningful. You need to understand. You need to memorize this one. Then if it is mutually exclusive, automatically the last term will be 0. Then it will simplify to second one. I hope you may understand this one. Then I will go to multiplication. Multiplication will be applied when 2 or more events simultaneously. Some events, 2 events simultaneously. So it means PA and B. A and B happen together. But there are some rules you need to understand. If they are independent, then PA. A may happen. The result does not affect at all event B. A and B is totally independently working. For example, is a survey of American Automobile Association AAA, triple. It is usually AAA. AAA revealed 60% of the members made airline reservation last year. AAA is automobile. They will provide lots of service to their members. I can't remember. It's 30 years ago. It's very cheap. 30 years ago, it's $10 per year or something like that. But now I don't know. The recent membership fees, how expensive it is. Then 60%, even though they are automobile association, auto drivers association, they made airline reservation. Okay, 2 members are selected at random, and then what they probably both made airline reservation last year. First person, second person had reservation. First person, second person is they are not family, they are not friends, they are not co-workers in the same company. They are totally independent person. If you want A and B both happen is N. A and R1 and RB, then R1 times R2 probability, just multiply. Each person has 0.6, 0.6. So 2%, both of them make reservation last year is 0.3, so 36%. So you need to keep in mind, if 2 events are independently, then multiplication PA and B is PA times PB. You need to understand this one. Next is if 2 events are not independent. Not independent means A happened, B is affected by the result of A. A is affected by the result of B. There are some relationship. No. So in this case, we use some new terminology, conditional probability. Conditional probability is a likelihood an event will happen given that another event has already happened. So in what is PB? So we need to read this. PA given B. PB given A. It's differently. Is that B is already happened. When assume B is already happened, then what is event A is affected? Assuming that B has been already occurred. The second case is probability of B, assuming that A has been occurred already. It's different. And this conditional probability represent PB given A. Is a PB probability of B given A. So PA and B was PA times PB if A and B are independent. If they are not independent, you should follow this. PA and B is PA multiplied by PB given A. Or PB times PA given B. So if A and B are not independent, you need to use this formula. If A and B are independent, you need to use multiplication. Okay. Examples. A golfer has 12 shots. He has 12. in his closet, line has white. Others are blues. It's a 9 white and 3 is blues. He gets dressed in the dark, and so he just grabbed a shirt and put it on. He played golf 2 days in a row, and do not return the shirt to the closet because after 1 day is used, you go to the laundry. So do not return. Then first one is, so I will calculate, erase. Let's assume he choose one shirt. He choose one shirt is P white. So how many shirt? 1, 2, 3, 4, 5, 6, 12. Okay, total 12. White has 9. 9 of 12, right? Is 0.75. What is probability that he has blue? Blue means they have 3 out of 12. And P white is 75%, P blue is 25%. But now I will go back to you need to understand this calculation. Any questions here so far?
No, sir.
Okay. Here is a P white is 0.75. P blue 25%. But my question is, when he choose 2 things, W and white and blue. So if he choose here, important, do not return. If he return, first day he just return. Let's assume he may use the same thing next year. Second case is not return. P white and blue is first 0.75 times 0.25 if he returns. Case 1. Case 2, PW and PB is not this one. Any student can explain why it is not equal to this one. First one is return is total 12 shirt. Among 12, 3 are blue, white, 9 are white. The same thing. But if he do not return, it will be different. Let's assume he used white on first day. Total number of shirts will reduce to 11, not 12. Right? White has not 6. They have 1, 2, 3, 4, 5, and so. It's 하나, 둘, 셋, 넷, 다섯, 여섯, 일곱, 여덟. Okay. First day he used white. Do not return is 8 white and 3 blue. If he use first day blue, then total the second day is 11, but 2 blue and 9 white will remain. So if he do not return or return is totally different meaning. Return, then PW and PA are independent. Do not return the remaining 11 combination 8 white or 9 white. Or it depends on what shirt you have chosen first day. Do not return it is not independent. Okay, so yeah, you need to understand what is the meaning for, okay? If they are if you say do not return, then with the first day, A and W1, the first day you have chosen, let's assume you have chosen first day white shirt. And second day, you have another one, the second day is also white and white. So it is equal to PW1 times PW2 given first day you have W1, white one. This is correct. 9 and 3, total 12, white and blue. If you choose white first day, second one is do not return, it will reduce to 8. 8 and 3. So total is 11. 11. Out of 11, A shirt will be white. So secondly, this is conditional probability. If you do not return, it will be depends on first day event. So you need to say W1 given W2 given W1 is conditional probability. It's totally different. And you multiply these two is 0.545. Any question regarding to multiplication? I will repeat. P A or B will be PA plus PB minus P A and B. If they are not, exclusive. If they are not mutually exclusive, you need to use this one. Venn diagram like this. Okay, A and B. P A and B will be equal to PA plus PB directly. The Venn diagram is A and B is mutually exclusive, but this part will be zero, nothing happened. P A and B will be equal to PA times PB if A and B is not, they are independent. If they are not independent, is PA times PB given A, or PB times PA given B. You can use either one if they are dependent. So PB given A, this part is called conditional probability. You need to understand these two formula correctly. So if it is mutually exclusive, another one is P not A is 1 minus P A. Okay, this all this note information and is included, is not included. You need to understand clearly about this one. Now I move to contingency table. And Bayes theorem and so on. Any question regarding to here? Rule of addition, rule of multiplication. You need to understand clearly what it means for independent or dependency and so on. And mutually exclusive or not mutually exclusive. You need to understand the terminology clearly. Contingency table, we have studied in the previous chapter, chapter 4, a table used to classify sample observation according to 2 or 3 and 2 or more identified category. So we need to divide our data into different categories and classes. For example, 150, total is 150 adults were asked. We surveyed if they are older than 50 years old, or the number of Facebook account more than 50 is a yes or no. The two categories, okay? Two categories. And Facebook account is no one or two or more, then we have some, 2 by 3 matrix format is calculated. It is a kind of contingency table. Okay, where am I? I'm probably here. Even though I have my Facebook, I'm not heavy user, but I will use my Facebook later when I go to Cambodia, But in Korea, I don't feel to, maintain my Facebook account and so on. So I do not use it at this time. But I have created Facebook, but I have nothing, no information at all. Next is tree diagram. Tree diagram is a visual is a kind of a visual diagram is helpful in organizing calculating probability with several stages. Each stage is a branch of trees and so on. For example, is number of movies attended per month. 1 month per month is how many movies you like? Nothing. 1 or 2 movies, 3, 4, 5, 6 or more. Okay. Event is A1, 2, 3, 4. Your age is B1 is less than 30, 32 up to 60, 60 or older. So in that case, probably young people, when you see roughly, young people see much more. Elders probably here. Interesting. But when you check it there, 30 to 40 and 60 is many people's answer, because more than 60 is 170 young people. They didn't, few people interviewed. So do not see compare the number directly, because sample size is different. Sample size is different. Okay. When you prepare like this, tree diagram like this, the first one is we will divide into by age first. Let's say 100. You need to keep it 100, 224, 175 among 500. So it's like that. Among 500, 100 is less than 30. 30 to 60 is 225. More than 60 is 100 something. It's a previous 175. Okay, 175 divided by 500. This is P. This one is P B1. This is P B2. The third one P B3. Okay, can you calculate what is means for? 15 divided by 100, just divide like this. 25 divided by 100, 55 divided by 100, 5 divided by 100. So when its age group is less than 30, it's event of 31, how many movies they are watching? How many movies are here? 0, 1 or 2, 3, 4, 5, and so on. So you need to understand 15, 25, 55, 5. So 15, 25, 55, 5. Divided by how many people with 100? I have divided by 100. Then 0.15, 0.25. So this number means, what means? P is A1, 2, 3, PI given P1. When the age group is less than 30. When the age group is less than 30, okay, how many movies they're watching? So the second one, PA1, the first one is PA1. This is PA1 given B1. Second one is PA2 given B1. Third one P A3 given B1. The last one P A4 given B1. B1 is already happened. Age group already decided, and then among that age group, how many percent? The next one is this one. I use different color. So total is 225. 50 divided by 225. 100 divided by 225. 60 divided by 225. 15 divided by 225. It is here. So this is P AI given B2. Age group is B2. Then what is probability? The third one is, third group is PAI A1, 2, 3, 4 given B3. Age group is 60 or more. Okay, what is PA1 and so on. And then you need to calculate. It's really like a tree. Okay, age group is 30 or less. Then how many movies are there? And then you need to multiply this, multiply 0.15. When you multiply this one, this is P A1 and B1. Among B1 is age group is less than 30. They do not watch at all. Okay. The second one, this is PA2 and B1. So it means you need to this multiply this. You multiply. Then the formula will be like this. PA and B is PA multiple PB given. One student entered late, please come to the class on time. If you come late, your lateness will interrupt my lecture, okay? So it is, in the middle is P, in the middle, this is conditional probability. This part is conditional probability. This is PA1, P2, PB1, PB2, PB3. Sometimes you PA or PB. Okay, in this case, B is age group. Then if PB, this is PB given A. PB given A or sometimes PA given B. It depends on. And then multiply this will be here. This is joint probability. This times this will be here. Joint probability. Okay. Your age group is what it means for. Your age group is 60 to 30 to 60. And you watch one or two movies, total is 0.2, joint probability. When you add all of them, joint probability summation, all of them is equal to 1.0. How about here? Summation here, this is 1. This is another, this is 1. This is 1. When you add up, this will be equal to 1. Okay? General rule of multiplication, P A and B is PA given PB given B, or P A and B will be PB. When you multiply PB first, PA given B. Conditional probability should be applied if A and B are not independent. If P and B is independent, then what happened? PA times PB. Okay. Then I have questions. First one is when A and B are independent. When A and B are not independent, the second. But when you compare these two rules, P, B is equal to PB given A if A and B are independent. If they are independent, PB, probability B is probability B given A. Event A already occur or not occur, it doesn't matter. Or another one is PB given not A. Not A means A is not happen. Whether or not A is happen or not happen, P conditional probability is equal to this PB when A and B are independent. Okay, but usually PB is not equal to PB given A because they are independent, not independent. If they are not independent, it's totally different. You need to understand this one. Bayes' theorem. Can I take a break here? Because the remaining lectures I cannot stop here. So it's better to take a break now, 15 minutes. Please come back to class, after a short break, okay? Don't be late. See you later.
Yeah, Professor.
Yeah. What happened?